welcome back to my channel, and here we are going to solve this question 3. And the question says that the sketch in figure 1 shows the plan and elevation of a square base pyramid drawn in first angle orthographic projection, and this is what they are talking about. Then we come to the questions that say, question A says that we are to draw, so A Roman figure 1 given view, and A Roman figure 2 says that first auxiliary elevation on plane XX. So let's first of all draw the given view, and then we draw the first auxiliary elevation as we are instructed. Then we come to question B, so which is part of the work on the square base pyramid as we are given. Then question C is a separate question on its own, which is also part of question 3. So let's work on question 3A, Roman figure 1 and Roman figure 2. Then we'll come back and also answer question 3B. Then later we'll work on question 3C later. So let's start. So what we need to do now is that we need to look at what we are given here. So this is the front elevation of the square base pyramid, and this is the top view or plan, and then we're asked to draw the auxiliary elevation on this plane XX as we have here. So let us side of the square base is 40 millimeters and the height of the pyramid is 45 millimeters. This plane XX is inclined at an angle 45 degrees to the horizontal. So let's first of all replicate what we are given first, which is part of what they are going to mark for us. So let's start. So the first thing that we are going to do here is that I'm going to draw a vertical center line, so like this. Okay. Alright, then I'm going to draw a horizontal center line here, horizontal center line like this. Okay, then I'm going to take a measurement of 20 millimeters because the length of side of the square is 40. So from this point here, I will take 40 millimeters. That is the point where the vertical center line and the horizontal line in the center line intersect. So I will take 20 to this right side. And also I'm going to take 20 millimeters up and down here. So setting the set square like this, I will take 20 millimeters down from this point, and I'll take 20 millimeters up. So here I'm going to draw a horizontal line, so like this. And here also I draw a horizontal line up here, so like this. Then I will draw a vertical line, so I can make it a thick line at once. So I will make this a thick line from here to here. Okay, so I will also make this a thick line from here down here. Then I will also thicken, so a distance from here to here. Also I will thicken the distance from here to here. Alright, so the next thing I'm going to do is that, so I'm going to join the corners together. So I'll join the corners together, so like this. So join the corners together like this. So I will also join these corners together. Alright, so now let's draw the front elevation as we are instructed. So I moved my T-square up like this, and then I will draw a horizontal line here. So here, so I'm going to draw a vertical line from this point. A vertical line from this point here to meet the horizontal line, and also from this point I will draw a vertical line to meet the horizontal line. So now I will take the height of the pyramid. It is 45 millimeters, so we have 45 millimeters here. So now I'm going to connect this point. So I'm going to make this a thick line, so connect these 2 points together like this. Okay, then I will also connect these 2 points together, so like this. Okay, then I will thicken the base also. So then I need to extend this horizontal line. So based on the way that we are given there, so I extend this horizontal line, and this top also, I will also draw the horizontal line. So okay, so with my 45 degree set square, so being set in this direction, So at any distance, so I'm going to draw the line. So that line XX, which is the plane. So plane XX, I will draw this. So then I will call this X. So this angle here is 45. Now we want to draw the auxiliary elevation, which is what we're asked to do. We want to draw the auxiliary elevation. So what we are going to do, so I'm going to number this point as 0.1, this is 0.2, this is 0.3, so this is 0.4. So we are going to project line at angle 45 degrees because the plane is at 45 degrees. So we also need to use 45 degrees. That's what they expect us, so that we can draw lines that will be perpendicular to this line. That's what we want to do. So from this point here, we are going to draw a line at an angle 45 degrees from this point, and from this point. Also from this center here. So let me call it center hole here. So that's what we are going to do now. So then from here, so from this point to here, I will draw a line that goes in this direction. So I'm still need to extend it, so I'll do that later. So then from this point 3 here, so from point 3, so I'm going to, so from point 3, so I'm going to draw a line in this direction, so which also pass through point 1. So then from point 4, I will also draw a line like this. So that line that we drew from 3 also passed through point 0 here, or point O here. Okay. So that line was not okay. So now, so the next thing that we are going to do now, so is to bring out the shape. Okay. So when I'm looking at this object in this direction, I'm going to see this line from 2 to 3. From 2 to 3, I will see it. So what that means is that I'm going to make this line. So point 2 is here. So we have this point and we have this point. So this line connect them together. So I'm going to make this line a thick line like this. Okay. So we also have this point 3 joined with point 4. We see this line, point 3 to 4. So we see it. So that means this line, we need to make it a thick line from here to here. Okay. So that's what we have now. So the next thing that we are going to do is that as I'm looking at the object, so it's a pyramid. So I need to get this point, which is 45 from the base. So I'm going to take a measurement of 45 millimeters. This is center line. This is the center. So I will take 45 millimeters from here. So this is 45 millimeters. So we are going to see a line from this point here, from this point 3, that will be joined with the apex. So that means we have to make this line, we make it a thick line like this. Make this line a thick line. Also, I will see a line at this point 2 here that is joined with this point, which is the apex. So let me call this point, let me call it point V, as we have here. So this is V, and let me call this V1. So we are going to see a line from point 2 being joined with the apex. So I'm going to make this line a thick line. So I will draw from here to here as a thick line. Also, so we also see this line being joined together with the apex. So I will also draw this. Alright, here we have the auxiliary elevation, as you can see here. So that's the auxiliary elevation. So the next thing that we are going to do here is to answer question 3b, which says that measure and state the true length of the edge of the pyramid in 3a. Okay, so in 3a, as we are told, so we're asked to measure and state the true length. So we need to find the true length. So when a square is positioned in this form, so this line is not the true length at all. So we need to find the true length. So how can we get the true length? What you need to do is to put in point of your compass at this point O here, or point 0. Then you extend to point 2 here like this, and you draw an arc. So when you draw this arc, okay, So we draw the arc from point 2 like this. So wherever it touches on this horizontal line that comes out from point 0 here, so you have to draw a vertical line. Okay, so we draw a vertical line from this point. So from this point here, so where the arc touches the horizontal line, so draw a vertical line to meet the horizontal line that is drawn out of the base of the pyramid here in the front elevation. Then we have to join this point together. So let's call this point, let's call it point P. Okay, let's call this point point Q. So we join VQ together. We join VQ together with a straight line like this. Okay, so this line VQ is the true length. So we usually write that with TL. So it's the true length. So we're asked to measure and state the true length VQ of the edge of the pyramid. So I'm looking at this. So this is 54 or 54. So we have 54. So that's 54. So I just say true length, that is TL. So true length of the edge of the pyramid is equal to 54. So plus or minus 1. 54 plus or minus 1. So we have answered question 3A and B. So we meet on the solution to question 3C. Thank you and God bless you.